here's the key word, intervals. The book also, I like the way the book sets this up. It's a little different than it did last year, which I'm finally glad they changed it because they were kind of like a little off last year. But they do large samples, we use Z-scores. They do small samples, we use T-scores. They use variance, we use chi-square tests. And it's separated very nicely. When we go to the next unit in hypothesis, they follow the same order. So you're going to see like a little bit different flow with your book. So just kind of hang in there. The information is basically the same, but we've tweaked just a little bit. So we're going to improve our chances of finding our population mean by not picking one point, but by picking an interval. Okay? And that little margin of error is our little wiggle room. Okay? So from here to here. Like if you say to your folks, they say you have to be home by 10. Like how rare are the chances that you're going to hit it exactly 10? What if you're 5 minutes late? You're going to get yelled at. I said 10 o'clock. Be home at 10 o'clock. So you say, okay, Mom, 9:45 to 10:15. Just give me a little space in between there. And I know we're going to a movie. We're going to go stop and get a soda or ice cream afterwards. Like anywhere from 9:45 to 10:15. Isn't that better for you to hit? And then if you come in at 10:05, it's not so bad, right? You say, I know I'm going to be a little bit late, or I might be a little bit early, depending on what time the movie lets out. So you give yourself a little wiggle room. That's your interval. Okay, and that's easier or better than finding just that exact point. Okay? Same thing with shopping. I'm going to give you $20 to say, well, maybe I might need a little bit more. All right. So we're going to estimate your population parameters. In the past, we did your samples in the last unit. Whenever we found your population for your mean, we said your sample was the same exact as that. So therefore, we're going to be able to use your sample mean as a point estimate. We're going to use this as a point estimate. We call this guy the point estimate. There's great calculator steps for this unit too for confidence intervals. And when we get rolling into the intervals, I'll show you on your calculators, and it's so nice on your calculator. So we'll get the concepts down, and then we'll worry about the calculators. Now, you all remember how to find your mean of your data set, right? So if I look at example 1, and I have a list of data. I have 40 examples. I didn't write them all out, but it's in your book. If I have 40 examples, how do I find the mean? Add them all up, divide by 40. How do I find them in your calculator? L1. So you're going to put them in L1. You're going to find me the mean. I'm looking for the X bar. This is a sample. I don't need your sample standard deviation. You can take that out there. This is your sample, because we're not going to use your sample standard deviation. So I want your S bar. This is your point estimate. We need somewhere to estimate this interval. So plug them into your L1. No, just plug them in and find me your mean. We're going to need this for your point estimate. We're going to need your X bar, your mean. Yes, I realize it shows you there. Just example 1. Yeah, I just want you to get used to doing it. Plug it in your L1. Find me your sample mean. Stat, enter. You can use any table. You can use L2, L whatever. But when you go stat calc, one variable, make sure you set your table to whatever one you use. So everybody come up with the mean? 29.6. Now, we also said when we round the mean, it's always one more decimal place than your data is. Your data has no decimal places. So your mean has one more decimal place than your data. when we look at margin of error, it's going to match this. It's going to have one decimal place also, whatever your mean has.
Is that right? Is that what everyone else got?
29.6. So is everybody good with that? Okay, now, there's a sample of 30 out here. And I don't need you to do that one, but would everybody know how to do it, right? So this X bar, if we do this the same way, is 28.9. There's 30 employees in the country, and they found a random sample of 30 employees. And they found that mean to be 28.9. These are the hours worked by 30 grocery store employees versus the 40 grocery store employees. Okay, so same process, we find the mean. Okay, that's the easy part. Now, since your probability of finding your exact mean based on your sample is very rare, we're going to make an interval. In order to make an interval, we're going to put your point estimate, bless it, your point estimate right in the middle. And we're going to give a plus something and a minus something to both sides. This in here is your margin of error.
A box of whisper?
It looks like a box and whisper, doesn't it? These have to be equal on both sides. Now, if I want to know what my margin of error is here, how can I find it? Without using a formula, if I have my point estimate and my left end and my right end, and this in here represents my margin of error, how could I find it? Good. Subtract the endpoint and minus from the mean. So this would give me a 2.1 margin of error. Now, there's a number of ways you can write this. We're going to be writing it like this. The mean plus or minus the margin of error. So we're going to say 29.6 plus or minus 2.1. And you subtract 2.1. God bless you. God bless you. You get to the other side. God bless you. We're also going to write it in interval notation. So it's going to be from this part to this part. A number line is nice to look at when we do this because you're going to be able to see if your intervals widen or narrow. And your intervals don't get bigger or smaller because your numbers between each number are always infinite. They're either going to get wider or they're going to get narrower. Or we can write it like this. This is what's going to make more sense to us. This guy. This is going to tell us that our population mean is going to fall between these two numbers. We used your sample information. We used your sample as a point estimate to estimate where are we going to find the actual population. And we'll make an inference about your population based on your sample. This is where we're headed. These are just the parts to get there. Now, we also deal with a level of confidence. I'm just giving you all the pieces because they'll all fit together. Your level of confidence is the probability that the interval estimate actually contains the population parameter, assuming that we've done this and repeated this a number of times and we did everything correctly. Now, when we do your level of confidence, they're usually 90%, 95, 99, 80. They can be weird numbers, but usually they fall into like the 90, 95, 99. How confident do I want to be that this population is flowing here? In the medical field, how confident do you want to be? Fairly or very?
Very.
Very. In the field of, I'm looking for the average of all my statistics kids, fairly. I don't need to be pinpointed exactly. So it depends what we're measuring. It depends what we're looking at. Now, key to this guy is this piece right here. And I put this on your notes as well. So pick up your note page because we're going to do some of these together. To find your ZC, the Z-score associated with that confidence level. You need this for your formula. We're going to do this the same way that we did these before, finding your cutoffs before. Here's a 90% one. 90% of your curve falls in the middle. Your curve is symmetric about the mean. So 90% falls in the middle. We want to know this score, this score. They're going to be the same. One's going to be a minus, one's going to be a plus. So all we need to do is look up the left end. So I need to know this area over here. Well, if this is 90, what's left over from 100? 10. And I only want this side, so half of 10. I want 5% in here. So we say 1 minus 90, that gives me 10%. I take the 10% and I divide it by 2. I get 0.05 is sitting right here. And same as the last unit, when we need to find a z-score, we use inverse norms. And we say 0.05. Now, it's going to give us a negative 1.645. And of course, we know this side is a positive 1.645. When we write the z-score, we only write the positive. Because we're developing our margin of error, we're going to use a plus or minus anyway. So we only need to put the positive z-score in here. Now, to make life easier, you can put this whole thing in your inverse norm. Parentheses, 1 minus 90 divided by 2. But you have to remember your parentheses. Otherwise, it'll divide the 90 first and then subtract it from 1, and you don't want that. So you can kind of bypass that a little bit. This is your inverse norm in here to find it. Keep this chart handy, because when we start doing these problems, you don't have to redo this work all the time. Most of your confidence intervals will be 90, 95, 99. So when we look for the ZC, you can take it right off your chart. If we want to add some more, like if we do an 80, and we're about to do an 80 in a second, you can add it to your chart. Just keep track of it. So if we did 80%, 80% of my curve is falling here. How much is left to share in the tails? 10 and 10, so 20. 100 minus 80 is 20. And divided in 2, this is a 10, and this is a 10. Everybody agree? So we're just going to do an inverse norm on 0.10. You can do the inverse norm on the whole thing. You can do 1 minus 0.80, parentheses, divide by 2. Inverse norm will let you do the whole thing. So if we do an inverse norm, try it, guys. What did your z-score come out to be? So what do we get when we do an 80? 1.2, two decimals. 1.28, 2 decimal places. Z-scores are 2 decimal places, except for these weird ones. Remember I told you there was another one besides the 645? 99 uses 2.575. If you rounded it, I don't really have a problem with it, because once we get to do these, probably you'll do them in your calculator, and your calculator takes care of its own rounding. So can we find this? Right? We're going to take 80 and put it in the middle. We're going to take what's left over, divide it in half, and do an inverse norm and look up that. If you prefer, and you want to look it up in your chart, your table 4 chart, it's a little longer, but you can look up 0.10 in the area section and extrapolate to your z-score. That's a little bit tougher to do.
What do they mean?
Extrapolate. We did extrapolation. Like what we go between two of them. We can find that's the 6, 4, 5. Every once in a while I have to use big words. Alright. I want you to turn to page 305. God bless you. And I want everybody to do 6, 7, and 8. Go over this. Now, when you get to this, guys, understand what you're doing. You want 85% in the middle. When you need to find your area to the left, you need to know what that area is under the curve, and then do the inverse norm. So 2 ways. You can subtract this out here first, and then divide it by 2, and get 7.5. You can put inverse norm, 0.075, and get a z-score of what, 1.44?
Yeah.
Or you can let the calculator do this division and subtraction, and then you don't have to worry about ever getting it wrong. But make sure you say subtract in parentheses, then divide by 2. Otherwise, it will do the 0.85 divided by 2, and then subtract that from 1. So make sure it looks like that. Now, same exact for this guy. 75% in the middle. So how much is this going to share?
So we were 6, 7.5.
Big money. Well, 12.5 each, 25 altogether, so 12.5. So 0.125. Or let inverse norm do this. Don't pack up yet, guys. Look, how easy is that? Let inverse norm do it. Keep your mean at 0, your standard deviation at 1, because you're looking to return a z-score. So what z-score did we get for this? What was our z-score for this, guys? 1.15. Put these on your chart since we did this. Go up there and add them to your chart. And the last one, 0.97. So we're sharing 3%, so 0.015, or let the calculator do it. 1 minus 0.97 divided by 3.
Divide by 3.
I'm sorry, divide by 2. Good, Nick. Divide by 2.
Yeah, buddy. Thanks.
And you should get 2.17. Remember, you're looking at the negative side. I want the positive one for that chart. No, I don't need the negative. Yeah, but you're actually looking up the negative.